So the first one, we have Dave. He asked, how can recirculating air can be safely set up in a woodworking environment, specifically the entire unit being inside of the building, and how it can be safely designed? The heating, cooling costs associated with venting air externally can be huge. So mainly the question, how can recirculating air can be safely set up in a woodworking environment?
If you want to recirculate the air from any dust collection system back into the plant, you can do it, but it requires a number of additional considerations that you have to review. So with woodworking, the biggest thing you have to consider is fire safety and combustible dust safety. So specifically, when we say combustible dust, as we mentioned earlier, it's actually two things. It's not just do things catch on fire, but it's also explosions, and both of those can happen with woodworking dust. So if the dust, as an example, if you're sucking the air in and there is a fire somewhere between the pickup and the dust collector, right? We have to have some kind of system that stops it and breaks it so the fire cannot get pulled into the dust collector. In the dust collector, the main hazard is it exploding. So that's why we have the explosion vents on the dust collector. A fire is also bad, but explosion is much worse. So most of the requirements have to do with stopping or safely venting out an explosion. In most cases, if you exhaust the air out, the main hazard is removed. If the dust collector is outside and you're exhausting the air out, you pretty much just need three things. You need a explosion isolation valve that stops the duct, the explosion or fire from going backwards through the duct into the dust collector, or back from the dust collector back inside the building, right? Then you need the explosion vents on the baghouse, and then you need to exhaust it out, okay? And if that happens in an explosion or a fire anywhere in there, it will not propagate and become worse. If you want to recirculate in is where the problem comes, because now, if there's an explosion in the baghouse, let's say, and it's running, you have the fan pulling air out of the baghouse and then pushing it back into the building. There's a fire or an explosion anywhere upstream, the fan will take it and push it back into the building. And that's why it's tricky when we have woodworking. So we basically have to add another layer of fire and explosion isolation on the ductwork that goes back into the building. So it's not a big deal. Sometimes we can use an abort gate, a high-speed abort gate. Sometimes we have to use a combination of a fire break shutter and an explosion isolation valve that will slam shut. But we can do it. If you put the dust collector inside the building, that's kind of related. It's not exactly the same of recirculating, but if the baghouse wants to go inside, it can be done. But again, it just makes things trickier. You generally have to have the explosion vent go outside, and you can't have a very long connection. So you'd have to put the baghouse right up against an external wall, cut a hole in the wall where you can have the explosion vent ducted just a couple of feet, like 2 or 3 feet through the wall so that it explodes and vents outside in case something happens. You could also put it inside anywhere if you want, but then you'd have to have a flameless explosion vent that would let the pressure out while snuffing out the flame front in the event of an explosion. So putting it inside and or recirculating the air back in for fire safety, it can be done. You just have to have a bit more equipment. The last thing with recirculating the air is for health and safety inside, kind of also related to the fire safety as well. Because if you're running the dust collector and something should happen, let's say you suck up a nail or a piece of metal or something, and it cuts a hole in one of the filters. Now the filter is going to be leaking, so dust is going to get by and go through the fan and exhaust it out. If that happens and all you do is exhaust the air out, you just blow dust outside, you get in a problem maybe with the county for an air permit violation, or you can quickly see it, fix it, and nobody's the wiser. If you're recirculating the air back in, though, all of that dust that leaks just gets blown right back into your building. Now, in woodworking, that's bad, especially bad because you have combustible dust. Now you're recirculating it back in. You're basically blowing in combustible material and depositing it nicely all over your building, especially on like elevated surfaces, like on top of machines, rafters. So in that case, sometimes it's required, sometimes it's not required, but it certainly is a great idea, is you need something in the event that you have a leak in the filters. So traditionally what they do is they have you put HEPA after filters so that after it goes through the filters in the bag house, goes through the fan, and then you blow in, it goes through a set of HEPA filters that don't really do anything because the dust collectors already captured everything, but they're there in case you ever have a leak in the filters in the dust collector. And they capture everything so nothing gets into the plant. A little riskier, but a viable and reasonable way to do it instead of the HEPA filters is to have a very sensitive bag leak detector or filter leak detector in the ductwork after the filters. So that way, if you get any leakage, it'll go off right away, and you can shut down and go take remedial action to change the filter or whatever it is. Sometimes we can combine that with a abort gate so that if it detects a certain amount of dust coming by, the abort gate will slam shut and open on the top, and it'll blow all the air out to the atmosphere. So you do have a problem, but you will not be blowing dust back into the building in any case. So if you do those couple of things, you can make the recirculating the air absolutely possible. And a lot of our customers do that, and we're able to help them with that. It just requires that extra investment and just makes the system a little bit more complicated. But in places where you have a lot of heating and cooling costs, or you need to really control the humidity inside, for example, I work with a couple of major guitar manufacturers, and controlling the humidity level inside the building is so important that for them it's worth it to have all these extra devices and extra procedures because just dumping all of that conditioned air out into the atmosphere is a huge waste of money. So for them, it makes sense. Have it go back in and add these couple extra safety devices and procedures, and then there's no problem.
All right. So the other question is, uh, can a dust collection system be over-designed to avoid issues if a branch is added later?
So the short answer is yes. When we design a dust collection system, we like to design conservatively. So if we add up all your pickup points and you need 5,000 CFM, we're not going to propose a 5,000 CFM fan and a bag house that will just barely make it with for 5,000 CFM. Usually we'll have a safety factor of 10% or more. I'd say 10% at a minimum. And then if you think you're going to add some pickup points later, then certainly we would add a safety factor. We bump that up a little bit. It is important to keep in mind that when you add a pickup, it changes the calculations on the ductwork fairly significantly. So even if your fan is big enough, your baghouse is big enough, if you just kind of willy-nilly add, drops here and there, this balance of your system is going to change. You may end up having, you may starve the other pickups depending on your airflow capacity. You might end up with your velocity through the ductwork that's already there being too fast or too slow. So you might be wearing out elbows or having dust sowing. So it's important that if you're going to make changes to the ductwork, that you have a professional come and look at it and properly engineer it. Changes can be made. It doesn't have to be a huge science project, but it is important to note that you're changing the ductwork balance. So I wouldn't do it casually.
Good. Okay, next question. What type of damper is typically used to balance dust collection systems?
So a damper is just any kind of gate or valve that lets you partially or fully close off the duct. We usually refer to these as blast gates, but there are barometric dampers. There are other kinds that are used in ductwork. The terminology is kind of loose, but basically it's some kind of gate or valve that partially opens things up. Balancing the dust collection system is important because if you just hook up a whole bunch of things, um, because different branches are smaller or longer or have more twists and turns, they end up with more resistance. So the fan doesn't know that you want this much airflow here and this much airflow here. It's just going to pull air, and the branches that have more resistance to them will have less air pull through them, basically. So sometimes if you have multiple pickups, you get more in one spot than you think you want, and you get less over here where you need it. So then balancing is where we basically, with the gates, on a branch that has too much air going through it because it's let's say it's close to the dust collector, it's just open, very low resistance to that branch. What we would do is with the gate is we would partially close off the duct and artificially create more resistance there. And then because now that branch has more resistance, the air is going to look for the path of least resistance, and it's going to kind of, we can think of it as be diverted over to the other pickups. So always a good idea when you have multiple pickups, include a basic blast gate on all of the pickups at the ends, because you can always use them to balance a little bit. And if you ever need to close it off completely for some reason, you have the gate there, you can do that too. If you want a really advanced system, we can do systems that have automatic blast gates where if the machine is on, the gate opens or closes. If you go really advanced, you can get gates that to maintain a certain airflow based on how many gates are open, it will automatically turn the fan speed up and down so that you get consistent airflow all through. Those are auto gate systems, and those can get very, very useful when you have a lot of machines, but it is an investment. So if you want to look at something like that, please talk to us and we can take a look at your system and see if it's a good fit for that. If by damper, though, what you're meaning is the damper on the fan, that would be a damper that's used to artificially create pressure on the fan so that it pulls less air. That could be part of balancing a system, but generally when we say balancing the dust collection system, we're talking about the ductwork upstream of the dust collector, not controlling how much air the fan is able to produce.
Good. Excellent. So next question, how can blast gates be used in smaller applications like school woodworking shops to assist with balancing?
Yeah, kind of going back to the same thing. They're used all the time. So if we, depending on what the customer wants, oftentimes we will have blast gates that are on every single pickup. So, maybe the customer has a very small system. They don't, their budget is limited. They're only planning to use one or two pickups at a time, and they want to, conserve by closing off the pickups that are not in use. We'll just put a blast gate or a slide gate on every single pickup. The customer can use it. There is a caveat or warning, I would say, when you do that, depending on how the ductwork is designed, you do run the risk of starving the trunk line and having dust settling and so forth when you're opening and closing pickups. But, it happens all the time. People do it. You just have to be aware of it.
Awesome. From your experience, how much extra capacity should engineers consider when selecting a fan?
I generally recommend people do anywhere from 15 to 25% extra capacity. Part of that is in case they want to add something later, because almost everybody wants to add things later, and you can never make a baghouse bigger once it's in. So much better to make it a little bit oversized. I also always just recommend we oversize it a little bit anyway, in case some of the calculations are off, either yours or in the process of installing things, we have to reroute something or add another thing here or split something. Having that little bit of a cushion is always a nice thing to have. And it just always, it takes the dust collector from being, basically redlined under 100% stress that it's designed for. When it's at 80 or 90% of the stress it's designed for, the difference in performance is huge. It'll work a lot better. So I always recommend 15 to 25%.
Awesome. All right. It says, do explosion vents come standard with dust collectors, or do they need to be specified during selection?
They do not come standard. They're commonly added. It's kind of an optional adder for a regular dust collector. The way they are sized, first you have to go do a dust hazard analysis. So you take a sample of your dust, you send it over to the lab for a DHA. They'll give you all the dust explosivity values, the Pmax and KST and all this stuff. Using that and the volume of your baghouse, you can calculate the size of the dust vent. And it is important that you have someone knowledgeable do that, because if you undersize them, of course, then you're not adequately venting. If you oversize them, you may be overpaying a little bit. But there is a process and an equation basically for calculating vent size.
All right, so the next question is, how do I determine the correct airflow required to each woodworking machine in my facility?
As we said earlier, most of the machines that you're going to have, the manufacturer of that machine has already determined how the venting of the hood design is and how much airflow it needs. That's what we call the ventilation design. They've already done all of that. So the clue that they leave you, if they don't write it in the manual, the clue they leave you is what size port is there on the back of the dust collect on the machine. So if they have a 4-inch port there, what they're telling you is, okay, hook up this 4-inch port with the velocity of the air velocity that's used for woodworking dust collectors, which, as we said, 4,000, 4,500 feet per minute is very conservative. If you hook up a 4-inch and you move the air that fast through the 4-inch pipe, then you'll figure out the airflow by looking at the chart, like we said, 485 CFM for 4-inch, for example. Sometimes you find in the manuals and things like that, but it's not very often. And then you just add up all of the ports together, and that's how you end up with the total CFM you need. If you don't have dust collection built into your machine already, you need to consult with us, and we need to see how it makes dust and all those things. And we might have to come up with a custom hood for you, and then that can vary a lot how much the airflow is. But that's not so common with woodworking applications. So most of the time, you've already got it there. You just need to find the port size and then apply that formula that we talked about earlier.
Awesome. Next question. What are the warning signs that a dust collection system is undersized or not performing properly?
So classic warning signs that your system is undersized or not performing properly. So the basic kind of functional metric for a baghouse or dust collection system is the differential pressure. So that's the pressure across your filters. Usually, they're designed to operate between 2 and 5 inches water. That's kind of the pressure range you're looking for. If you go out and you look at your baghouse and it's pinned at 10 inches, or maybe it's 6 to 8 inches, what it's telling you is that your filters are blinded or your filter cleaning mechanism is not functioning, and it's like a big warning red light for your system. So answer number one is differential pressure too high. That's a big warning sign. Functionally, when you start to lose suction at your pickup points, when you get your brand new system, everything is, great suction and airflow. It's just pulling the dust right out of there. Everything's good. You come back a couple years later and maybe it's not sucking so much. You're not getting the airflow you need. It's dusty in your shop. That would be sign number two. And usually I would say the two are related. So your suction is lower because maybe your differential pressure is higher. You may have accumulated dust in your ductwork over time, so you should probably have an inspection done to make sure you clean out your ductwork. Or maybe there's some other issue going on where your fan is not pulling as much air as it should be. So that's where we would point you back to our the standard quarterly or daily, monthly, quarterly, yearly checklist type of items. But if you have nowhere else to start, check the differential pressure on your baghouse.
Great. Awesome. Very thorough answer. Excellent. The next question, are floor sweeps a good idea in woodworking facilities, or can they create problems in the dust collection system?
This almost sounds like a loaded question, but so floor sweeps are very convenient for shop operators because when they clean up their shop, they just sweep up everything into the floor sweep. That's great. It's convenient. I would want one if I was there working a saw all day. There is definitely a downside to floor sweeps, and that is that everything that gets swept up into them will go into your baghouse, into your dust collection system. So we just finished a job at the Marine Corps Logistics Base box shop. We pulled the old system apart, and the trunk line was half full. It was like a 24-inch trunk line, halfway full with nails, staples, gloves, chip wrappers, trash, all kinds of stuff. So you can imagine, if you're pulling nails into a fabric filtration system or even into a cyclone, and it's going out through a rotary airlock, it's just going to wreak havoc on your system. So if I had to pick one, I'd say no floor sweeps. There's too much risk of messing up your dust collection system. I get it. They are convenient. Yeah, if you really trust your shop personnel to not sweep up nails and trash in there, then go for it. But I guess don't be too surprised when you get some bad stuff in the dust collection system.
Awesome. All right. How do you properly size duct branches when multiple woodworking machines operate intermittently rather than continuously?
Yes, you can design your system for pickups that are used intermittently. When you first provide the basic layout and list of machines to us, we will often ask you to specify whether these machines will be used continuously or intermittently. Based on that discussion, we may design the system a little bit um, smaller than normal to account for the fact that not everything's always going to be running. The ideal thing would be if you have, let's say you have 10 machines, 7 of them are running all the time, 3 of them you only use once in a while. Or maybe you have a combination like, okay, you run 5 of them all the time, and 5 of them you only run occasionally, but when you run those 5, you don't run the other 5. Those kinds of things you need to discuss with us or your dust collector OEM who's designing your ductwork and sizing everything. Generally speaking, the best would be to just design the system big enough to run all of it at the same time. But if you're really confident that that's not necessary, we can usually meet you somewhere in the middle. So if you have 10, if you only run 5 all the time, I wouldn't suggest we size it exactly to the 5 because we have problems with getting the ducting the right size for the velocities with all the connections. But generally what ends up happening is we meet you somewhere in the middle where like it's like 7. So it does end up saving you a little bit. But yes, absolutely. You can design branches of the duct and the dust collection, the dust collector and fan with that in mind. You're only going to run some machines intermittent.
And the last question. What type of filter media is typically recommended for softwood versus hardwood dust?
I might let Dominic take a stab at this. My initial thought is that, polyester, standard 16-ounce polyester filter media is probably fine for both. In almost all cases, it'll be just fine. You might have some case where you're using polypropylene, but for wood shops, we're not talking really high temperatures. We're not talking really abrasive dust. There's not a lot of moisture. And those are kind of like the 3 big things that drive filter media selection. So I would say it's not going to matter that much, but I might let Dominic, he knows more about the filter media, so maybe let him take a stab at that one.
All right. Okay, Dominic, do you have any insights on that question?
Yeah, no, Matt's on the right track there. It really doesn't matter with regards to hardwood versus softwood. Um, Polyester bags, if you have a bag house, is the standard. And then if you have cartridges, we usually recommend the spun bond polyester cartridges because they're open more. There's more spacing between the pleats. But that's for physical characteristics. You have the nano, the 80/20 with the nano on top. I mean, that's not going to matter. Softwood versus hardwood, that doesn't have any impact. What has an impact are things like moisture, things like if there's any kind of oils, resins, or treatments on the wood, things like if there's high humidity because you're in a humid area or it's coming off of like a dryer or something like that, some kind of process, and you have a lot of moisture that's in the air, and it's hot and sticky. Like those things matter about picking the media, but just all things being equal, softwood versus hardwood doesn't make a difference.